And today we are going to discuss, we are going to go through how we can move towards a citizen-centric government, but in the era of agentic AI. So the current year 2025 started off with this promise that AI agents will start rolling parts of the IT solutions and business automations. So we thought of having a session around the emergence of agentic AI and its implications on building a citizen-centric government. So the way I have organized the session today is I'm trying to map to the digital economy initiatives that you all have formulated, and I'm trying to sort of associate with your national AI strategy that you all formulated and released in 2024, and its citizen-centric goals. And then how can we improve towards moving our goals into these citizen-centric government initiatives using AI as a driver. So once we discussed all of that, once I present all of that, we can probably get into a fair bit of details of some of the AI technologies that are presently being used world over in most of the solutions. And especially I would like to start with the generative AI, which is an inflection point in artificial intelligence, and then we'll try to move towards some of the technologies that will be very relevant to building a citizen-centric government, which is retrieval augmented generation, agentic AI, and then we also will move towards AI governance and try to understand how we can govern AI, because especially unlike in the case of previous probabilistic models that we have been using over years, like the machine learning, the traditional machine learning technologies, the deep learning, even for that matter, we did not have the challenges that we are now having with generative AI. So therefore, the challenges and risks associated with generative AI should be considered in detail when we are formulating our strategies. So this is the digital economy blueprint that you all have presented. This is an evolution of your thought process around building a digital economy. I think this spans about 10 to 15 years. Former ICTA, they formulated a blueprint towards moving towards a digital government. So if you look at about 5 to 6 years back, what we were trying to do was we were trying to move towards digital transformation or digitally transforming government, because that is an essential ingredient of moving towards other initiatives as well. So the way I see your digital economy blueprint is, of course, you all have overarching guiding principles that you all have formulated, which is extremely important because it spans across towards your other blueprints, other frameworks as well. So the inclusion is a critical element that I have identified in both your digital economy, the strategy for digital Sri Lanka in 2030, as well as your AI strategy document. Inclusion, trust is a critical aspect, because if you use AI and if you try to automate, try to simplify tasks, try to improve government operations, the users of AI technology should trust that the outcomes are something on which they can make decisions. And unlike in the previous, I would say previous technologies that we have been using, like predictive analytics, where we were trying to understand patterns using machine learning technologies. The moment generative AI comes, generative AI has along with it certain levels of risks, which at times are frightening. So therefore, the trust, how to build trust is a critical aspect in our discussion today. Governance and then sustainability is also a critical aspect, because the moment you start using generative AI as it stands today, it has a significant environmental impact. You all know, depending on the type of foundation models that you will use in terms of delivering AI outcomes, the environmental impact can be very significant. And the challenges associated with building trust towards using these generative AI models is also fairly complicated and difficult. So sustainability aspects of, we look at it from two sides. One is, of course, how AI can be used to improve the sustainability goals of the government. The other thing is the impact of using AI towards our sustainability goals. And then the other aspect of critical aspect that we see is in terms of overarching guiding principles is the human literacy in terms of using AI in this context. And then, of course, you all have come up with some critical elements of regulations, especially the Personal Data Protection Act. However, we are still short of coming up with an AI Act. So we will also discuss about the importance of formulating an AI Act and sort of making it a guiding principle towards the use of AI. So using these overarching guiding principles, what we see is you build your digital IT infrastructure, which is based on your Lanka government cloud primarily, and you all have plans of moving towards multi-cloud and hybrid cloud infrastructure. You all are now looking towards LGC 2.0 plus, and then you are trying to move the workloads to a service provider, and then you are trying to build on top of that cloud, perhaps to move ahead with more sort of sovereign cloud plus a hybrid cloud that will integrate with public cloud providers. So you all have that strategy in terms of your government cloud strategy. And then some aspects that I would like to bring is, along with that, one critical aspect that you all have to think through, the Sri Lankan government has to think through, is to build what we call AI factories. So AI factories are very critical in terms of generating intelligence from the data that we feed in. So they are just factories that generates intelligence that is required for simplifying your operations, improving the operational efficiency of the government, and help in making decisions. So we'll discuss about what this concept of AI factories and how we can move towards that. There are certain initiatives that service providers have already taken up. I think quite recently, one of the service providers have started thinking along those lines, and they are trying to sort of come up with a requirement specification and go ahead with that initiative as well. So on top of the digital IT infrastructure, you have digital public infrastructure. Some of the aspects that probably needs to be included in that is, now, of course, the current blueprint talks largely around the payments, the unique digital ID, and other aspects of verification, verifiable identities, and authentication. In addition to that, you will also talk about national data exchange, but one of the critical aspects that we need to look into in terms of operationalizing AI would be the Government Information and Process Exchange. ICT has started as an initiative about maybe about 6-7 years back, maybe slightly more even. That is where you all try to build a common framework of automating business processes across departments. And then the other initiative that needs to be considered is in formulating your digital public infrastructure is AI factories. So the few areas that I would want to cover before moving into specific AI technologies are, first, of course, the AI factories. We need to try and understand the impact of an AI factory in terms of delivering the promise of AI. Now, there is a significant amount of importance of among governments the sovereignty of data, the fact that we need to try and maintain some of the information, especially relating to citizens within the country, and should not be storing them in hyperscalers or public clouds where we do not know exactly where they are stored. So because of that, even Gartner has identified the trend towards building sovereign clouds, digitally sovereign clouds, which requires you to perhaps have infrastructure that is able to support your AI initiatives within those sovereign clouds as well. So AI Factory is one such initiative that has come up. In fact, this is a sort of I would say, a functional and a techno-functional block diagram about what AI Factory is. So AI Factory provides the capability for you to consume data and then using both CPUs and GPUs with different characteristics to be able to do training, do pre-training of maybe foundational models, do training of your machine learning models, and then to help serving those models for inferencing. Which is, inferencing means you want to make use of that, and when you actually go and chat with one of the large language models, essentially you are getting that large language model, so you are inferencing using the large language model. So when you probably have a machine learning model which want to predict, for example, hospitalization, the number of hospitalization, the patients of specific category that are likely to get hospitalized within a particular period of time. If you want to do some predictions, that actually is underlying what is running is a machine learning model, and that machine learning model, you actually do inferencing on that machine learning model for you to get the predictions. So inferencing and training are two aspects that we need to consider. So both, especially in terms of using foundational models, where we try to drive outcomes of generative and agentic AI, those inferencing time, compute processing requirements for those models, especially agentic AI. If you use agentic AI, because if you use generative AI, basically you're doing a conversation, you're asking a question, and then based on the tokens that you feed in, the model will try to complete based on the training data that it has. But in the case of agentic AI, in addition to the completions that the model would do, model, before doing any completions and getting a response across to you, it has to do reasoning. So we'll talk about that later. It has to do reasoning. So there'll be multiple reasoning tokens that will be consumed, that will be consuming the GPU cycle. So which means more you go up the ladder of AI, more will be the compute GPU capacity that you will use. So therefore, for different types of workloads, depending on the inferencing workload that is coming onto them, you should be able to have an infrastructure which is able to run those workloads in the appropriate GPU resources, on top of appropriate GPU resources. So you need to have an orchestrator. Now, in the case of this, it's based on Kubernetes, which is one of the world's best known orchestrators of compute infrastructure, container orchestration platform. So you use the container orchestration platform with the intelligence that this workload needs to be located on CPUs at this time. At this time, this workload needs to go to a GPU of these characteristics, and at this time, this has to move to another GPU. So GPU aware, GPU characteristic aware orchestration is what we need to do in terms of running these large language models or foundation models to do during inferencing time, as well as if you have to train huge billions of parameters you want to train them, you probably will consume this amount of GPU capacity. So therefore, you need to have that infrastructure that is able to do orchestration of the workloads across GPUs and CPUs. So which is what an AI factory would do. AI factory would then serve the models for inferencing, and then it's something like you can have your own applications. You can build your use cases, which consumes the the foundation models or machine learning models hosted by this infrastructure. So essentially what is going to happen would be you will be feeding in data, training the models in this infrastructure, and inferencing those models during inference time to get the required outcomes that you want. So you feed in data, get the intelligence out, get the outcomes out. So that's what an AI factory is all about. And then I tried to sort of simplify your digital economy, the digital economy, the framework that you all have built for the blueprint that you all have built for the digital economy, to try to understand how we can apply AI into how we can relate AI into this framework, or rather the blueprint. So if you look at the blueprint, the topmost layer is basically what we call the channels layer, the citizen interaction layer. It will be citizens, the general public. It can be private sector. It can be any other departments of the government. But it will be citizens who will be interacting. So, but you want to make your digital economy blueprint citizen-centric. For you to make it citizen-centric from an AI perspective, from the channels layer, what you can bring in is the conversational engagement. Now, that is what we do not have. Today, what you have is a website. Like largely, you will have websites. Sometimes you will have human interaction in government departments. So we had moved from websites to maybe mobile. You probably would have moved in certain departments, mobile-based interactions, because now we are trying to, our digital natives and AI natives are now coming into mainstream interactions with government. So when they are coming into that mainstream interactions, because they don't know anything other than being digital, because they are digital natives, so they would actually want to interact using digital channels. And with the AI, what we need to build is this conversational AI infrastructure in the channels layer. Then the other important thing is, as Gartner has predicted, most of the applications that we are building today, in another 2 years time, they will become AI embedded intelligent applications, meaning those applications themselves will start thinking, start reasoning, and coming up with outcomes themselves, and to be able to carry on those outcomes as they move ahead. So into your industry applications and government application layer, which is feeding into your channels layer, you need to embed AI. You need to start building AI capabilities into those applications. So there are different ways of doing that. Now you all have initiatives for modernizing government applications. At the same time, you all also have released recently the RFPs that you all have released. You all have clearly asked for those applications, even the large government applications that you all are going to come up with. You all have requested them to be cloud native, which means they can be changed quite fast. They are modular. Applying AI, embedding AI, and infusing AI would be quite easy, because it's not like infusing an AI into a monolithic application. So you all have taken those steps, but the important aspect is, when we consider the AI in respect of your digital economy blueprint, we need to start having initiatives in terms of bringing intelligence. Whenever you release RFPs or tenders, you need to be able to ask which area you have to think through, and you have to challenge your prospective bidders to be able to think through, not just to move it to cloud in a cloud native infrastructure, but going beyond that, what are the type of AI techniques that you're going to embed? Are you going to do optimization within the application? So yesterday we had a discussion with Sri Lanka, one of the largest conglomerates. They are into manufacturing industry. What they said was, we are actually modernizing manufacturing execution system. So what we understood was, they are looking at in terms of optimizing their manufacturing runs across the plants. They would want that optimization to be done not based on rules, but based on machine learning. So they want to embed intelligence in place of rules. And at the same time, they would want to have a conversational interface with the manufacturing execution system to be able to query, to be able to converse and see how the manufacturing operations are going on. So that's the type of thinking that our private sector has, and that's the type of thinking that we also should start having in terms of bringing on or modernizing our government and industry applications. Then going down bit in your digital economy blueprint, this is not there. Still, I believe it's a very important aspect, which is what I would call as national process exchange, which is something that I have seen in other governments, where you try to build this common process automation layer on top of which you can start standardizing your process automations across your departments. So not all processes are part of the government applications. So you will have RAMIS application, but there are a lot more things that are happening outside of the RAMIS application. There'll be your RMV will have their own application, but there'll be lot more. For example, onboarding, there'll be a number of processes that will happen outside of that government application, right? So those things needs to be automated. So for them to be automated, you need to have some form of a process automation and orchestration platform. Now, Gartner believes that it has to be what they call business orchestration, BOAT. So it's a platform that they're talking about where most of these automation technologies will start converging. So that sort of a platform, cross-governmental platform of that scale, is something that we need to think through. And now what is going to happen, that layer also will start getting AI infused. Why? Any process automation layer up to now was operating on hyper-automation principles. You all built workflow automation, you all used robotic process automation, you all used document capture and capture automation technologies, you all used rule-based decision automation technologies. Now that's what the process automation layer had been up to maybe about a couple of years back. Then we started embedding machine learning techniques. Now we are starting to embed agentic AI technologies into our process automation layer. Therefore, what is going to happen would be the level of automation that the process automation layer is bringing is going beyond the traditional hyper-automation toolkit's capabilities, and now it is incorporating agentic AI as well. So AI agents will start taking on some of the processes which require human reasoning. So that's where we should start focusing on in terms of your digital economy blueprint. And then connected government infrastructure is extremely critical, because the moment you start going into the agentic AI era, you are essentially allowing an agent to interact with the environment. You're allowing an agent, assume that you are building an agent to provide a conversational interface to automate a process that spans across multiple government departments. So you want that particular conversational interface to originate a process that starts from one department, goes to another department, and then ends up in another department. If you want to do that, your agent should be able to interact with this environment. It should be able to interact with these three departments. For it to be able to interact, it needs to have this connected government infrastructure. It should use the connected government infrastructure, and it should use what we call standardized tool calling. We'll come to that later. Tool calling techniques to be able to, from the agent, to be able to identify, okay, I should start my process, perhaps this particular requirement, let me go to department 2 and get that done first before going to department 1. So it will dynamically think through. For it to think through, it needs to have this connectivity infrastructure. So connectivity infrastructure is an enabler. We probably may need to sort of uplift in terms of allowing other protocols like model context protocol, the context protocol that we probably will talk about, that allows an agent to communicate with what we call an API. We may need to enable that, but underlying connected government infrastructure is a critical element. The other thing is for you to be able to run intelligent applications, intelligent application, meaning agentic AI embedded applications, machine learning embedded applications, as well as for you to run automation, process automations using AI capabilities. You need to have this module serving platform that is provided to you from your AI factory. So that's how AI factory comes into the picture and enabling your digital economy blueprint towards AI. Then obviously, national data exchange, something that you will have spoken about for almost a decade now. Probably you will start operationalizing some aspects of it. National data exchange is an extremely critical aspect in terms of training some of the models. It'll make it easier for you to train models, because now you will start having data that has been exchanged from multiple departments. But obviously we are still at early stages, because I had a discussion with IRD the other day. IRD was saying that the amount of effort that they are putting into, I would not want to mention the name of the department, to get connected with that department, that government entity. So we are still very early. We are talking about something that will happen in the future, but I'm saying it will be very critical for us to, if the data gets exchanged, if the data exchange infrastructure is in place, how easy would it be for us to train our models on that data? Because it's already shared. The infrastructure is already in place, right? So this is how I envision you should start thinking of AI enabling your digital economy. Now, trying to figure out, you have come up with a national AI strategy document. So if you try to dissect, what you're talking about is, I am trying to go through this AI strategy blueprint, the sort of a framework where the guiding principles and what you're trying to do is formulated. I'm trying to go through and try to extract some important information. So in terms of making AI centered around the citizen keeping the citizen in the middle, and we use AI to make the citizen-centric engagement. Two aspects from the national AI strategy that we can think through, because you are talking about, one thing is inclusivity. The other important thing that you're talking about is accelerate the realization of AI. So this is very, very important. Who formulated this has thought through. We cannot wait till our digital national data exchange gets operationalized. We cannot wait till the connected government blueprint gets operationalized. We cannot wait. We have to accelerate and bring AI outcomes. So that is what they are saying. If you look at the middle part of it in the national AI strategy, they say accelerate the realization of our AI vision. What are they trying to tell you? They are trying to say improving public service delivery. So for you to improve the public service delivery, AI-driven automation, is where we should start focusing on. Any process flow that starts kicking off, serving the citizen, needs to have AI, so that we take out human element when it is not required. And we use that human element in more productive work, and therefore we actually improve our human capacity, the capacity of human capital. Because nobody would want to do 4 or 5 years the same data entry operation, taking something from a piece of paper and typing it on the computer for 3 to 4 years. Because as human capital, they are not gaining anything, they are not developing themselves. So therefore, what we need to try and do is, we call it in private sector back office. So which is the operations side of people who are doing operations, who are essentially operating on the request of the citizen to fulfill that process. We need to start looking at AI to automate it. And then very critical aspect that is being taken up in this is stimulation of adoption of AI in private sector. Now, for that, what can you do? Obviously, they will start going ahead, because they are in competitive. They are in a competitive landscape. They do not have a monopolistic position as some of the government departments. They must use AI to reduce their costs and improve their operational efficiency. They are anyway forced to do. But what can you do in terms of helping them in their AI journey? You have to start exposing your services as fast as possible. Connected government needs to be realized. We need to start somewhere fast enough. You need to push the capabilities outside as APIs, very simple APIs. The other important thing is when you start AI initiatives, for you to scale in a boundless way, if you need to sort of scale fast and fast, you start seeing the okay, so this particular, again, that private sector customer was saying that they have multiple subsidiaries. So they said, I got a very good buy-in from one subsidiary when I implemented. That triggered the same conversational chatbot to be implemented in another 3. So it breeds, success breeds success. So for us to accelerate, however we are government, however, we need to do something very important. We need to have our AI governance infrastructure very, very, very solid, because any decision we make out of AI has to be trusted by the citizens. So that means we need to have solid governance. So I have some slides around how we can implement AI governance. You need to have automation. You need to be able to see exactly how these agents, if it is Agentic AI, how we would probably audit what they are doing, like what you're auditing the human beings. You need to be able to backtrace and figure out how did they make this decision? What were the things that AI agent thought through before making the decision? So that governance framework has to be implemented. So this is a very important thing, and your AI strategy document captures that. So we have 3 aspects of AI governance. One is life cycle management of that AI model, and the second is evaluating the model risk, how risky it is. EU AI Act stipulates, European Union has formulated, and now it is law in European Union, AI Act. In that AI Act, they say you cannot use AI for these use cases. Cannot. Prohibit. This you can't. If you are using for these use cases, this is the level of transparency and explainability your AI models and your AI ecosystem should have. So they actually have EU AI Act has been formulated based on a risk-based approach, and now very clear in EU. Any government entity is very, very clear where can I use AI. If I use AI for realizing this particular use case, what level of governance should I implement? They know, it's very crystal clear. So if your act is clear and clean, and by the way, your Personal Data Protection Act is very, very clear. It's very well crafted and all that. So likewise, if you come up with this act, it's very easy. That will allow you to scale, because you don't have you don't have to think now this cloud thing. The banks can't go to cloud, and this customer data has to be in country and all that. Yeah, for the last 10 years, banks are talking about this same thing. Why? Because there's no specific, unambiguous guideline that is formulated or a law that has been passed to say this cannot be done, this can be done with this. Nothing. That prevents innovation, that prevents us to move forward. We'll be behind even Bangladesh. So now we are going to migrate our applications from VMs to cloud when Bangladesh has implemented their container-based cloud platform. Because we were part of it, and that's why I want to say. So I'm saying, to scale AI, governance is a must. Right. So this is an example of use case. Since finance ministry, I thought tax and customers. I extracted, in fact, I couldn't actually quote. I extracted this from McKinsey report. In McKinsey, they have done a very, very important analysis and a research around areas and domains where government can start thinking of using AI. So for tax, these are things that you all would probably know better than me. Import guidance. When you do import, what needs to be done? Go for a virtual assistant, not get them to talk to 10 people and get that process into their heads. Make it simpler. Real-time document verification is an important aspect. So we have a use case that we will discuss about document validation. AI can do a tremendous job of validating documents, validating a payslip in terms of identifying whether the payslip is genuine or fraudulent or tampered with, and cross-correlating payslip with any other information from that you get from your employer. Now, this probably would be important for a bank, perhaps not for you, but I'm saying maybe utility bills. You all do KYC information, so validating them. So these are very, very heavily used AI use cases. Risk assessment summaries. Risk assessment in terms of, for example, now banks do, I know about the banks, so we work with Bank of Ceylon and all government entity. So they have to do integrated risk assessment for large transactions that they do, and in fact across all transactions. So you can actually get the data in from those. They are doing for money laundering, but there are other aspects of fraud that can happen that needs to be validated. That's where AI can very extensively be used. Most of the anti-money laundering systems still use rule-based, not AI. Right. Real-time tax filing. So we all file tax real-time now, almost from a portal, right? So if we have some agent, sort of not an agent, assistant, AI assistant, that is popping up and saying, not just the all day bots, but real AI assistant coming from one side from the IRD portal and telling, okay, now I am stuck in this particular place. What should I do? Now that's the type of thing. So these are very important things. I will share with you all that particular research report done. It was a analysis report done by McKinsey, a very comprehensive one. It talks about many industries, and this is one of them. Okay, now we'll switch gears and we'll go and try to dig a little deeper into in the other technology, AI technologies. Before that, we all have any questions? So the level setting I've done, and now we can move into these areas a little deeper. And the areas that I'm going to cover would be generative AI, retrieval augmented generation, agentic AI, and AI governance. Do you want anything else to be covered, or are they okay, or you have any thoughts on that? Right. So we'll then start. Right. So now this is, of course, from expert systems that IBM built long time back towards the generative AI era, how AI has sort of moved. So what we had was about maybe 1990s, late 1990s. Of course, we started off this machine learning based predictions and all of that in 2013. We started off by predicting which customers of a bank would default a credit card payment, which factory workers in a apparel industry customer would churn out, because churning out or attrition of factory workers for our apparel industry is a very, very big thing. If you can predict it, it's very, very important, because they can do planning, they can start retention programs and all of that. Churn of customers in the telecom industry, and values in data collections that you all have done. Central bank has done data collections, and there are certain values that has probably not got populated, that has been missed, using machine learning to populate them. And then on rain prediction, weather prediction. So those are types of things that we did long time back, 2014, 15, that is using machine learning. In machine learning, you all know, right? So you all probably know very well about machine learning. What we do simply is we use a training data set, and we try to find the optimal algorithm to predict what we want. It may be a classification problem, it may be a regression problem. Assume in this particular case of defaulting, whether this customer would default a credit card or not. whether I should grant a loan to this customer, pre-approved loan to this customer or not. Binary classification. So you know the target, what you want. You want to predict which customers would default. And keeping that as the objective function, you use different machine learning algorithms to try and find the best algorithm that would actually use the features of the customers in that specific case, or use the features of features that you capture from the HR application for the factory workers. Use those features. Features means what? The demographics. The factory worker, where he's coming from, married, unmarried, all lot of other information, other features that you get. So you use the features to figure out what pattern, in what combination of these features have given rise to a customer defaulting credit card or a factory worker churning out. That's what we did 10, 15 years back using machine learning algorithms, right? So then deep learning, self-driving cars to image processing, this traffic vehicle detection, all of those things where you need to actually train. So you probably train, how you train using a data set where you know the outcome. Okay, so so we call them, so you use a data set, and if you can use supervised learning or unsupervised learning. If you use supervised learning, you label them, because you need to get the machine to understand what that particular feature is. You label it, and using the label data, and you train the model, and then get an outcome. So the problem with these types of models had been, machine learning models, they are not general purpose. The model that I developed to predict the attrition of factory workers in the garment industry customer cannot be used to predict credit card default. I cannot do that. So they are singular purpose. Then, of course, we are now moving towards self-supervision, self-supervised models, or the models that are foundational in nature, which can do multiple tasks. The same model can be used to do multiple tasks. So those are foundation models. The most popular foundation model is the large language model, and then we have large reasoning models, we have large action models, we have time series models, which are pre-trained. Now those have been trained, so you don't need to train them, but you can do some techniques can be applied to use them for your purpose. Well, you just can adapt them, you don't need to train them again. So that's why the generative AI era has grown quite remarkably fast in terms of the usage, in terms of popularity, in terms of use case realization. Right, so this actually now these slides, by the way, I have to inform now, all these slides are from IBM. We are not going to do any sort of marketing for IBM or promoting of IBM technology, but just to get the content across to you. And this is very, very well articulated, because IBM is one of the leading AI. They have been leading AI solution provider for a long time, and they have very good documentation. So I extracted all these things from them. So here what it says is about how long it took for ChatGPT to get to 1 million users. So what it says is, the moment something that is conversational, something very closer to you, and a model that can be used for multiple purposes. Now today we are talking about multimodal foundation models. The same model can be used to sort of do text-based inferences. You can use the same model for image-based, generate an image, generate a video, sort of get the model to understand the video. So those are multimodality, can also be done using foundation models. Then these foundation models these are the type of attributes as I discussed. So they are self-supervised. They learn themselves based on large amount of unlabeled data. You don't need to label them. Labeling is a very expensive operation. So you give it a large amount of data, it will start identifying patterns, and it will start putting those, convert them into tokens and put them into that multi-dimensional vector space. where it will actually get the tokens that have contextually similar meaning closer to each other with shorter vector distance. That is how it will start start understanding what you say, and then start generating outcomes as well. Right. So this is what I said. So basically, okay. So this I didn't explain. So here what we are saying is we are using the benefit of a foundational model because it is generalizable, meaning the same model can be used for multiple tasks. I can use it for classification. Classification meaning, for example, I am getting say huge number of service requests. When I distribute Aswasuma, I get huge number of complaints. So if somebody wants to classify these complaints based on what is contained in them, you can use the same model that you use to say generate a summary. So that means multiple types of tasks can be done, can be operationalized, or can be executed, and you can actually get the outcome using the same model. The other thing that these models will allow you to do is, this is very important, these models will allow you to do a little bit of task specific tuning. If you want to do something very well, for example, assume a scenario where you would want a large language or foundation model to know about tax domain very, very well. Tax domain in terms of how the VAT works, how the SWAT works, the rules, all of that. If you want to get it trained, so that it can be used to get responses to any type of question in this tax domain, what you do is you take a large language model and then you specifically fine tune it for that particular domain. Now, what we are seeing as a trend in these foundation models is, rather than being a large one stop for all, the large language models are now becoming more purpose built. Specific purpose only they serve. Tax domain, finance domain, HR domain. So there are specific models that are getting trained on those specific models that are coming up. Now that is something different. That is, you are building a foundational model from scratch for a specific domain. So those we call domain specific models. Those do not have the size of a general purpose model. General purpose model will have about, say, 60 billion, 70 billion parameters would have been used to train it. Trillions of tokens would have been used to train it. But then this domain specific model will have only a smaller, very clearly defined domain on which they are trained. So therefore they are small. When they are small, it's easy for you to run them, and easy for you to make use of them. The compute power that is being spent is quite smaller. So two things: either you can build from scratch domain specific models, or you can use a large language model or a general purpose model, and you can fine tune that model for that purpose. So the second one is about fine tuning a large language model. So we've got a number of large language models, different types of foundational models. We have models that will work on images, speech and audio, specific languages only. We can build a single only large language model. And then there are multimodal models which can operate on multiple types of modalities. And then text-based models were the ones that we were very much used to, which is like the original version of ChatGPT. And then there are reasoning models. Now, what reasoning models would do is, you can give it a complex problem which needs to be broken down. You will say, I would want the model to research about the compliance to SLSI standards in this particular industry during this particular time period. So if you want it to research that, it needs to now break it down. That question is a fairly complicated question. Complex questions are difficult for a large language model to, or rather a foundation model to answer. So what it will do is it go through a chain of thinking and try to break it down. Okay, now this is about Sri Lanka standards, and I have to figure out, okay, now this is about Sri Lanka standards. For me to get what the user is requesting, I want to first understand where can I get the information about the standard compliance for this particular period, and in this for this particular industry. So it will first try to say, okay, where do I find the information about this the standard compliance of this specific industry? Now for that industry, where would I be able to find the data relating to that particular period? So you might have to get this information from multiple sources. So then what it will do is it will do the orchestration. So it reasons out to get to where it wants. So those are called reasoning models. Reasoning models are the basis on which AI agents are built. So this is a very crowded slide. These are the use cases that are extensively being used by generative AI models, I would say about 2 to 3 years back. Now this has evolved a little bit. Customer care, that's for example that gentleman said about marketing department people are queried by the citizens. That's customer service. So you have this government information department providing information about anything. So that's customer service. So you have customer service in any of your government institutions. That's a very, very significantly used use case, which can easily be used using generative, easily being addressed. The challenges in customer service can easily be addressed. Thereby, you can improve the satisfaction of your citizens, get their queries resolved, and only the queries that requires complex decision making can be pushed to humans. The other thing is process automation, which they call digital labor. The other in IT operations, we don't need to talk much about that. That's a little complicated. One probably may not be very relevant to most of you all because you're from finance ministry. Cybersecurity. Now, in cybersecurity, you can extensively use generative AI to be able to identify specific challenges, you can actually analyze incidents, and you can extract certain information about certain security incidents, and you can also generate threat reports based on your security incident management systems. If you have many of them, you can actually get the information from many of them and do a summary and sort of generate the summary, do a report and all of that sort of a thing. In addition to all these use cases, one other use case is coding. Now, of course, there are companies that develop software where there are no human beings. So you just request it to, you give the functional specification to the company. There are no human developers. They will develop the agents will develop the software and give it to you. Right. Now, but we need to also understand the fact that generative AI is not a technology that can be used for all the things. It can do specific things very well, generation type things, specification type things, summarization, extracting specific types of information from a large corpus of information, things like that, doing some R&D for you. Those are the types of things that it can do. It can't do predictions, those types of things it can't do. Optimizations, that's not its job. So that's very important for us to understand. Now there's a slide that I actually got some information from Gartner. Gartner has done a very, 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 very interesting session based on their research about where generative AI should not be used. So I've got some slides. We'll discuss about those when we get there. But one thing I wanted to mention is these large language models, sometimes they start lying. They start hallucinating, we call it. They make mistakes, and that those mistakes can be extremely terrible. And I think you probably would have heard about those things, the impact that they can have. So that is why it is very important for us to understand how we can govern to figure out whether this model is hallucinating or not. What are the things that we can do to prevent it from making mistakes? That can be done in multiple ways. That can be done in the way you prompt it or the way you ask the question, or the way when the answer is given, you can just filter it out if you think that it is probably not relevant to the question. And sometimes the way it lies probably would be very, very complicated for you to figure out. You will ask about, say, for example, there was a very much viral incident about a particular person asking about the research articles, or rather a number of articles that he has done. And the large language model has responded as if it has read all those articles as an expert about that domain, specific domains, 5 research domains, 5 types of essays that were written. And the question was about getting an independent evaluation of some of the facts about this research. So without reading any of those, it has cooked up the responses and given. So that's completely because it was not able to access those documents. But what happens is when it can't accept, it probably gets into an association where it starts thinking of somehow responding to it. And so those are the types of risks. Those risks needs to be contained when we are providing we are using these types of AI technologies for citizen-centric work. So the important thing about these foundational model is we need to exactly know which data it is trained on, whether it is trained on any data that has copyright protection, because then if that data is being used to respond to you, you can be sued. Or in fact, of course, we probably may not have laws, but then developed countries would have laws where if there's a copyright infringement, even in a response from a large language model or foundation model, there can be legal implications. So you need to have, the model developer should provide adequate transparency in the way that which data it has used to train its model. So there is this Stanford University has done a sort of evaluation across multiple large language models to figure out how I would say how transparent they are in terms of the inferences they are making, and they have come up with a report on that as well. So they have looked at various aspects of being transparent about the way the type of data that you have used, the type of algorithms that you have used to sort of cleanse them, then how you feed them in, how you enrich them, all of that, whether they are transparent in terms of providing that information. And then probably when you're building and training, the training techniques that has been used, so all those things, whether they are transparent. So when you have more transparency about the way that all the everything has been done in terms of training the model, if you have a particular issue, then you would be able to backtrack and figure out roughly this is where it would have actually failed. The other biggest problem is if the data that we are feeding into the large language model is biased. For example, if there is a gender bias in the data that we have feed it in, its responses will be gender bias as well. So those are very critical things. If our data is unbiased, if we sort of ensure that equal representation of in terms of gender, equal representation in terms of race, if we actually maintain the amount of the type of the data that we actually feed in as equal representation, then it is better. So that means when a model is trained, we should have mechanisms in place to figure out bias in the input data. How equal the representation in terms of equal data. Now, EU AI have very regulations around how you should use your biometric information, use gender information, and other personally identifiable traits in terms of making inferences, because that can actually cause trouble in terms of biased responses that are offensive to some communities and things like that. So those are very important aspects that we need to consider. These are very relevant to your AI strategy that you have formulated as well, because in the AI strategy you have stipulated the need for coming up with governed and using AI responsibly. Responsible use of AI is one aspect critically mentioned in your AI strategy document. For you to be able to become responsible users or responsible providers of AI services, you need to be able to understand all these things. Transparency, obviously, we spoke about. The other thing is explainability. Explainability means you should be able to exactly trace back and say how this decision was made by the AI agent or the generative AI model. If it is an AI agent, you should be able to go to the reasoning traces to figure out what made it to go in this path to make this decision. We should be able to backtrack. It should be auditable. So your AI governance framework should be able to support auditability to provide the explainability of how the decisions are made. And then obviously about regulatory compliance, of course, very critical. Most of the governance platforms today has built-in guardrails to comply with specific regulations. In the Europe, it's like GDPR regulation, where how personal data needs to be treated. Here we have PDP. So whether you are in compliance with that information is very, very important and very critical. And then how customizable your model is also is a very important thing that you need to understand, whether they allow you to use the model and customize it for your own use. Now, Singapore government has a customer service in the MRTs, and that particular customer service, it's a sort of a digital human that is providing the responses. Now, they have used a version of ChatGPT that they could fine-tune for the Singapore government purposes. So that's what is meant here. Whether the model provider allows you to do fine-tuning. Obviously, in that case, it's a government to provider to government type of an engagement. But you should have control. So when it is sort of used by you, you probably have control because you fine-tune using your data that you cleanse, you know how you cleanse it and all that. So probably the information that the responses that particular customer service agent, the sort of the digital human in the MRT station would be sort of communicating with the commuters would be something trustworthy for Singapore government. So a few things, I probably think this will be a little bit more detailed. I will skip some of the slides. This is about, this is actually a tooling platform that IBM provides. Any AI solution provider would give you a tooling platform where you can improve how you get responses when you interact with a foundation model. So there are many ways of doing that. Now, the way we talk to the foundation model, we use the term prompt. We are prompting the foundation model, and then we get a response. So there are techniques like prompt engineering and prompt tuning that can be used to improve for a specific use case that we are trying to use the model for, the accuracy of the responses that we are getting. And those are very simple ones. I think you all probably would know, because you would always be doing prompt engineering by yourself when you are trying the same question 2-3 times to get the response back from a foundational model like ChatGPT. You are essentially doing prompt engineering. You are tweaking their question in a way that the model is able to easily and reliably complete the response. That is prompt engineering. But prompt tuning is a little different. That is where you send the model a set of labeled data. Meaning, for example, say insurance company wants to, so Sri Lanka Insurance, they want to categorize now the Sri Lanka Insurance can actually detect the severity of the damage to your vehicle using image processing technology. They can actually use video processing and all. They can detect that, and then for certain damages that are not so severe, they are able to detect the amount. Even I don't know to that extent that they can do. For example, if there's a specific claim made, and if you really want to categorize this claim into, say, for example, high risk claim, medium risk claim, low risk claim, or if there is a better example would be a service request made to insurance company, or for that matter, a service request made to IRP. If you want to get all those service requests and classify them, what you can do is, okay, you can, as a human, you can properly classify them, saying, okay, so these are examples of VAT refund inquiries. These are examples of, say, requests for rulings. These are queries. These are requests for clearance. So likewise, you can label them. You can get few examples, label them. You can get about 100 to 150 such label data set, where you exactly choose this was the request, this is the categorization. So you feed it into the foundation model. That is prompt tuning. So you're not changing the weights or changing the internals of the foundation model, but you're sending it a set of label data so that it starts understanding, okay, so this is the way I should. It trains itself a little bit without actually material impacting its internal structure. So that's called tuning. And these are things that you can do easily to get a foundation model to work the way you want. And obviously, for machine learning, these types of things you'll have been doing for a long time. So this is what I mentioned. Now, this is actually specific to IBM, but then others also probably would be doing something similar to this. Now, what this shows is how you can improve what process you do when you crawl the data from huge amount of data sources from the internet. How would you make the quality of that data improved before sending it for model training? The process they take. So these are very important. Now, the model providers or vendors who disclose how they do this, who make it transparent, are more trustworthy for you. So when you are selecting models, now model selection is also another important aspect that you all need to think through. Now I think the time is a little difficult for you all. Is it too much, or we have some more time, right? Because some of you all have actually now defocused and they start thinking of the next work that they are expected to do. So I was thinking them taking more time than what your attention span can be sort of drawn into me. Right. So the other important aspect is, this is exactly what I mentioned to you. Prompt tuning and prompt engineering. Prompt engineering you will do every time you interact with the model. Prompt tuning I explained. Fine tuning is, you are actually changing the internal state, internal weights of the model by providing additional domain-specific training data. So you take a general purpose model and try to make it a little bit more domain-specific by tuning it. That is not to say you are building a model from the scratch, but you're making use of a trained model, pre-trained model, to the domain. For example, the Standards Institute, they have specific technical information and huge amounts of standard information across many industries. Those standards are different, the technicalities of the standards are different, the compliance requirements are different. So lots of things are different. So you use that data to fine-tune a large language model, and then you use that as a domain-specific model for Sri Lanka Standards Institute. You can do that. And then what will happen is that model probably can be used to get responses to any type of query that comes against your standards by the citizens. So this I spoke about prompt lab, prompt engineering. So these are some examples. I think I took some examples and explained to you all these. So with this, and then I would actually want to get into the next two parts of this presentation. I would want to show you. We started off with the ChatGPT experience 2022. We directed specifically a model, a large language model. We specifically requested it on what we want the model to do. That is prompting. So you have to tell what it has to do, and then it will give you a response. Now the next evolution of that was, yes, of course, you have a model which is able to do a lot more tasks, multiple tasks. However, how can we use that model's capability of generation, capability of linguistic, capability of pattern recognition to be able to formulate responses specific to you, specific to your organization? Say, treasury, the way the foreign aid has been disbursed, the way you all have earned money from your from IRD, Excise Department, and all the patterns, all that information. Then probably any other thing that is very specific to the Treasury Department. If you want any private entity or any of your stakeholder, your maybe citizens, or any private any other entity that is requesting your services, if Treasury Department wants to provide detailed information, probably the other private entities may not be asking anything from you, but then other government departments want to query about certain things, then what you can probably do is you can get those policies relating to aid distribution, the allocation of funds and all of that, whatever the policies that you all have, whatever the documentation that you have, and you can build a repository. It doesn't matter whether it is a shared folder or a document management system, it doesn't matter. You just have to point, you have to build what we call a pipeline to get that information vectorized, because you have to convert them into vectors for us to do what we call a similar research. Meaning, like human beings, we'll ask a question, but there's no keyword. We probably ask about, say, I would want to know about, I would want to know the traffic condition if I want to travel to Kalutara. Then obviously, if a question like that comes through, that particular question, if you want to answer, okay, so that probably may not be a very good question. So if you really want to understand, let's take an example from tax department. Okay, now you come up with a scenario of, say, for example, a situation where you were not able to pay taxes in a particular quarter, and now you are in, say, after 2 years, you probably have received some sort of penalty notice or something like that. So you would want somebody to explain the reason why this penalty came or something like that. So that type of a question, normal standard foundational model will not be able to answer, because it doesn't know about these policies specific to Inland Revenue Department of Sri Lanka. That is where, as I explained to you, we can use retrieval augmented generation. And the Agentic AI, as I said, is the next evolution, which is this year's hot topic and this year's heavily used technique, where you start getting the reasoning capability to work. And that's what Agentic AI is. Agentic AI is about perceiving your query or your problem, breaking it into multiple steps, figuring out whether it has the knowledge to respond to it. If it doesn't have, to interact with the environment, interact with the other applications, interact with the websites, and get that required information in the order in which that you would want to formulate the response. Then you compose the response and give it back. So that type of technology is what Agentic AI is all about. Yeah. So we'll do a little bit more deep understanding about retrieval augmented generation. We spoke about this multiple times. So this term itself gives the meaning. We are essentially augmenting the knowledge of a foundation model by retrieving domain-specific data information from a repository of your own. Now that question, what I answered from that Standards Institute gentleman, that where we talked about retrieval augmented generation being used to address his particular problem, the queries from marketing department. What we are essentially doing is we are augmenting the knowledge of that foundation model by providing it access to all the standards related documentation that captures the response to that query. So for you to augment the knowledge, you have to retrieve the data from that standards documentation, which you share somewhere in a document repository. So that's about augmenting the knowledge of a general purpose model with the knowledge that you have embedded in your documents. So this is the pattern. I wouldn't want to get into details. It has two steps. First thing is we need to prepare the data. That means what's your organization's name? Sri Lanka Standards Institution. Yeah, Sri Lanka Standards Institution would have to do preparation of data. So what you do is you need to actually bring the data into one place, and then all that documents, if they're in electronic format, obviously they have to be in electronic format. If they are scanned, we need to extract the data and bring it to a readable format. Of course, even if it is not the case, we still can do. There are techniques of doing that. Then what we'll do is we actually break the data into chunks, and then for each chunk we create what we call a vector representation, and we store those vector representations in a vector database. So that is what this the top part is. Yeah, you can see that. Sorry, the top part is basically about preparation of data and storing it in the vector database. Why we store it in the vector database? Because vector comparisons are the ones that we can do with a large language model. We need to, what we are doing now is, of course, we converted all the information into an understandable format for the large language model or the foundation model. And then when a query comes from the user, what you will do is you pass the query and do a similarity search with the vector database. So then what will happen is that search is a similarity search. It's not a keyword search. It's a similarity search. Based on the concepts we are going to do a search to identify what is closest in terms of the response. So now what we do is, once we search, we will get if it is relating to that, the compliance of a standard for, say, tea manufacturing or tea distribution, then something related to tea distribution standards will come as a response. So you have the original user's question that was given to marketing department and the response that you have got from the vector database. You combine them and you send it to the large language model and ask it to give a rounded proper response, and then it will formulate the response and give back. That is retrieval augmented generation. This is a little bit more detailed one than this, but then the other thing is, now the retrieval augmented generation has moved ahead into its sort of it has advanced version of retrieval augmented generation. It has also become agentic in nature, which means assume that we don't have only one repository where all the information is available. We have about 3-4 repositories, and some of the information is not available in the digital form. It is available in the documentation form, but it is available in an application. So then you have to use an agent. So you have to pass the question to the agent. Agent would query those multiple data sources. Some of them were applications. It will figure out dynamically. It will figure out where the response can be, fetched from which information source, and then it will get the response back. Maybe multiple responses, and those responses will be sent back to a foundation model, and it will give you the response back. Right. So we are through with augmented generation, and probably we can move to the last part of this discussion. Do you have any questions up to now? Right. Yeah. So AI agent, as you know, is somebody who can operate on their own initiative. It's not like an assistant. So assistant and agent are different. Assistant would have to be given very specific directions. Agent does not have to be. Your insurance agent, if you want a renewal, on your behalf, it will think through, because it knows about your characteristics, your likings, your preferences, everything, your life situation, all of that lifestyle, everything it knows. Yeah, they know. Agent, the level of agency means how much of initiatives independently and autonomously that some of them are semi-autonomous. So there's a range of independence that agents would have. So in AI agents also we have different degrees of agency. For certain tasks we can give complete agency to an agent. For certain tasks you have to give semi-agency or partial agency to that particular agent and couple it with a human, saying very specifically telling the agent, if you encounter a situation where you have to think twice, or you probably have to talk to another agent or something, do not go and talk and try to get that response refined, pass it to a human being. So you have to specifically give instructions to that agent. Then it will only do the task up to the tasks that it has given autonomy to do. So that level of control can be made. So what really happens is the component of an agent's ecosystem is agent need to definitely have to have a memory to work. Now agent is basically a software system. So developing agents are fairly easy. You all can, if you all are software developers who can develop software, with a little bit of training you can develop AI agents very, very easy. But architecturally you need to understand how they would actually have to be set up, and use case has to be analyzed. So the critical aspect is a real business analysis you need to do to identify the risks associated with decisions being made by agent versus decisions made by agent with the support of human. So you need to figure that out. That's the tough part of it, but developing it is very, very simple. There are frameworks available now which probably will help you to sort of develop them. It's pure software development, nothing else. It's very, very software development centric work, with the subtle difference that to reason out, the agent has to rely on a brain, and that brain is the foundation model. So agent does everything but relies on foundation model to think through, do the reasoning. Right, so the components of an agent ecosystem is, it will have to do planning. When it has to plan, that means it has to plan how to resolve this specific issue. Now in this particular example, the question is, I need to know the weather of a particular city X. Now agent should know, okay, I have 3 weather applications. Out of these 3 weather applications, this particular city resides in this particular state. That state related weather information is provided by application number 3. And for me to query that application, I need this set of information, and I need to formulate that or format that in this particular format to send. So what it does is, it has to think through that. Okay, so what it will do is, when the request comes, there's a large language model or a foundational model where you have, foundation model will have all the information about the agents that are available, and at the same time their capabilities as well. So what it will do is, you send the query to the large language model. It will break the query into steps, and it will break it in this case. Okay, so this is about the weather. I need to talk to weather application. Okay, weather application, weather of city X. City X is part of state, say city X, say this is say Battaramulla. Battaramulla is part of Colombo. So Colombo city related weather information is available in XYZ application. So XYZ application has this API. So I need to talk to that application using this API. All that is formulated by the agent. An agent sends back, the large language model or the foundation model, and foundation model sends back, do this to the agent. So agent gets that API information with the data populated and send the query to that particular specific weather application and get the response back, and then again send the response back to the foundation model to formulate that response in a very conversational manner. That's what it does. So it has to do planning. When it is doing planning, sometimes most of the applications, agentic AI applications, will have multiple agents. Agents specializing in specific area. Now, in this specific case, it's simple. Maybe two agents. One agent is about citizen lookup agent. That agent will only do if a city is given, which state it is belonging to, it will only tell that. So that's the part of that agent's work. Then there's another agent who is basically querying agent, which queries the weather application. So you can have multiple agents like that, and then you can have orchestrate agents. So you can have an agent hierarchy that will work together to give the response back. Sometimes you have a situation where one agent would actually get a response and ask another agent to evaluate based on if that agent is specialized in evaluating, comparing the responses against the non-responses and figuring out whether this is right or not. So you can have a agent which would actually do the task and then pass it on to an evaluator, get the feedback, maybe two evaluators. One evaluator get the feedback, another evaluator get the feedback, and based on the way it is asked to do work, if both evaluators have given, say, more than 80%, it says, okay, this answer is fairly good, give the response back to the large language model, and from there, give it back to the user who requested it. So that's the type of operation that an agentic system would do. The tools that the agent would interact with the way agent would interact with the environment. Environment is the application. Now, for example, in the case of a query coming to the marketing department, that query is relating to I've taken step 1, 2, 3 to fill the application, but I'm not sure whether that application has got updated in your system. That's the query. So it will come to an agent, AI agent. Agent will ask the large language model, okay, now this is about, okay, so question about whether the application is updated or not, and he has given the steps that he has taken as well. Now then the large language model will break that question down. Okay, I have to do two things. One thing is I have to check whether the update has gone into the system. The other thing is I have to check whether the steps are taken correctly. So first I will check whether the steps are taken correctly without going and checking whether it is updated or not. Or sometimes it may think, okay, no, the faster way for me to do is, user is asking whether it is updated or not. I'll go ahead and check through the agent who is specializing in application status agent. I'll talk to the status agent and figure out whether the application has been updated or not. So it can go either way, depending on the goal. The goal is to be able to say, if the application is updated, everything is fine. If the application is not updated, you have to check whether the steps are taken correctly. So now the large language model has to think through which sequence I should do. So it thinks through based on the goal. Goal is to ensure that you respond back saying, not only to respond back saying it is updated or not, but if it is not updated, I have to say the reason, tell the reason as well. So therefore, it might think dynamically. First, I will go to the policy document to see whether the steps are taken correctly. If it is not, I will not even query to see whether the application is updated or not, because I know the application is not updated. So it might think that may be the optimum way to achieve the goal. And it will take those steps and get the response back. That's how an agent would work. This is a little bit more detailed, a little technical things, Today's you all probably would want to hear about more sort of practical applications based on this gentleman's first feedback. Only this gentleman gave the feedback. So anyway, thinking that it is representative feedback from everybody else, I would sort of not go into technical details, but then I will try to sort of go a little high level. We know the difference between Gen AI and Agentic AI. Gen AI is about you prompt and direct and ask what exactly needs to be done. I need to summarize, I need to do research, whatever. But Agentic AI is where you offload the reasoning of a task, or if you hand over a complex task which requires reasoning to somebody, to an agent, and let the agent work quite independently and get the response back. So the level of agency is also okay. The other important thing, quite interesting thing, is when you build agentic applications, because since there'll be some agents, some software developers here, I'm pretty sure if you get a hang of it, you have enough of frameworks like Crew AI framework is there. It's an open source framework. There are many other frameworks. Within a month, you will be able to do a very, very interesting agent development. Then you have to improve on architecture and all of that. So it's quite easy. I'm saying something that you all can easily do. The thing is, architecting that application. Okay, what level of agency, what level of autonomy should I give to the first thing? What is the agent architecture? Should I have to have an orchestrator agent and a number of task specific agents, or can I have just one agent? That's the architecture. For those agents, what is the best way of interacting with the application? Now, this gentleman said certain queries that comes to marketing department has to be responded by querying an application. So how to query that application? Now that's architecture. Then sometimes, depending on the steps of reasoning, depending on the complexity of the questions, you may need to store some intermediate data in memory. So how should I maintain memory? And then maybe this gentleman might say, oh, there are a lot of these types of questions that are repetitively coming. So then, for each question, you don't need to necessarily go and ask a large language model to do reasoning out. You probably, if it is similar, you get the question response and you store it in long-term memory. And if something similar comes, you do a similarity search and see whether there is a response back in the long-term memory, respond it back straight away without consuming the reasoning power of a large language model. So those are architectural things. But it's not complicated to build this. These types of architecture things, I think if you all are about 4 or 5 years of experience software developers, you all can pretty easily do. A little bit interesting slide around AI assistant and an agent. Now, this is an assistant. I think this experience you probably would have. So the question is, I need to transfer an employee on my team to a new manager. So this is very chatty. Chatty means, okay, so you say that you want to do a transfer, it's HR related one. So then you ask what's the name of the employee, and then what is the new manager, and then you go and do that work, of transferring. You probably interact with some application in the back end, maybe the HR application, and do that transfer. Before that, of course, you have to do many more things, because you have to check whether the requester has authority to do that transfer based on the type of transfer. If it is like a promotion, or if it is a from a lower authority to higher authority, and if that particular higher authority has sort of very risky tasks, authority on doing certain risky tasks. So those things has to be thought through. But if you are interacting with an agent, what you have to just do is, I need to transfer, say, someone to say Buddhika before the holidays and before the end of the year. That's all what you have to say. Just one question. Entire question you can throw and ask. But if you ask the same thing to the same thing from AI assistant, it would not be able to respond. It would figure out that it is okay. It's a transfer. Okay, I understand it is a transfer. Who is it that you need to transfer? Or it might ask, is it this person that you need to transfer? Because it doesn't have that reasoning power. Now, when this question is asked from an agent, the agent knows, okay, now it knows, okay, now it breaks it down. Okay, now this is about Saman to Buddhika. And there's a period also. Now, what should I do? I should first check whether the requester has authority to do a transfer, whether so whether Saman can be transferred to Buddhika's position, whether Saman's position and the Buddhika's position are different, or they are sort of at the peer level. is this transfer authorized? And probably since it is end of the year, is it okay for me to do a transfer now? So it starts reasoning out all those things. And then it decides, okay, I broke it down. Now I need to interact with the environment, because in my training data set, I don't have that information. It will be only available in the HR system. Okay. Now what I will do is, first I will go and talk to, say, employee agent, and I'll ask employee agent to fetch me the designations of current designation of the person of someone, and the intended positions designation. So these are things that we would think in our head as before doing something. So the same thing agent would think through, and it will actually give all the reasoning steps as well. Now I told you, when we implement AI governance, we need to be able to, the solution, the agentic AI solution should be able to very clearly indicate to you reasoning traces, steps that it has taken to, the steps of reasoning. Now that's what is given here. First step, it will do searches for the employees and new managers' details in the HR database and validates the transfer request. Then it will call the right HR application to complete the transfer and based on the information requested, received, and then generates and sends a confirmation email to the current manager, employee, and new manager. Okay. In this case, it does a little bit more well, because it knows this particular transfer is a process where there is a policy document which indicates if you do a transfer across peers or across individuals from one designation to another designation where the target designation is higher up, emails have to be sent immediately. So that may be part of the policy. So what it will do is the orchestrator agent will get it, talk to the policy agent, figure out what needs to be done. Based on that, it probably will do the other parts of the tasks that it needs to do. So this you can read through. These are pretty much the difference. Very important thing is, agent is always goal oriented. Whatever the ultimate objective or the goal that needs to be accomplished, employee transfer in line with the specific process laid out for the organization. That's the goal. It's goal oriented. And the important thing is, everything is done on the fly at that point, and considering that particular point's scenario, the environment. That is the important thing. So it's a goal-oriented, dynamic decisions, and then of course it has the ability to collaborate with other agents as well. So this is an example of an ecosystem where AI agent will start talking to a set of AI agents and AI assistants, which are in turn integrated into backend applications. So these backend applications are the applications that Sri Lanka Standard Institute will have against its specific functions of specific departments, something like that. So orchestrator engine is where you actually build and deploy the agents, and then obviously you will have one orchestrate agent maybe, and then you can ask employees to question. Now this is something that is getting a little popular, especially in some government institutions in European countries as well. I think in UK they have implemented for NHS, for certain national health services, for certain hospital trusts have implemented this, especially to be able to figure out when a new employee comes, if they do not know exactly what the process in terms of writing, sort of entering the details of maybe hospital, say about the patients, where if it is a health worker, where in which systems he has to update, in which sequence, which forms needs to be filled. If that process is not known, you don't need to go and get training. You just have to conversationally ask, I would want to I would want to I would want to do a hospital transfer of a patient having this particular sort of health condition. What steps should I take? So the steps are very well documented in, of course, those hospitals, very procedural, very clearly defined. So the backend system would actually query all the documentation necessary and get the response back and give you the exact procedure. One more thing is it doesn't, you should not actually use agents everywhere. There are specific areas where you probably can use agents. You should use agents whenever that particular reasoning is not so complicated that a human that there's not so much ambiguity, because ambiguous situations agents may not be able to correctly figure out at times. So there's a high risk. An agent, you are asking agent to do address situations which are ambiguous in nature, and for that type of work you probably might have to either build a rule-based decision flow, or you may have to build you may have to hand it over to a human being. Okay, so this is a little bit more technical. I'll actually not go into this. There are standard ways for agents to talk to each other as well as agents to talk to applications. So this is about the standard protocol that is used for communicating with tools. That means an agent has to talk to outside world. The way to talk to outside world is via APIs, right? So there's no other way. APIs or web search, or maybe it may be direct database access. The protocol that is widely used in terms of allowing an agent to talk to an application, a tool, meaning API or a database system or a particular application, is called Model Context Protocol. That was invented by Anthropic. Anthropic is one of the leading AI solution providers or developers of foundation models. It is now very much popular, and if you want to build an agent and connect to one of your applications, you can use this MCP protocol to create an MCP server on the application side, and you can get the agent to talk to that application and get the required information. The other thing is, of course, now to make the agent development quite easy, there are what we call agentic AI development platforms that have come up. So those platforms have pre-built connectors like MCP servers, pre-built for large commercial applications, like for core banking systems, for certain core banking applications, certain CRM applications, certain ERP applications like SAP and all. Pre-built MCP servers for your agents to talk to are available. Those are actually built into these types of agentic AI development and runtime platforms. So this is pretty much the same. Then this is an example of, I believe I got an example here. This is an insurance claim process that was automated in Europe. Here, of course, we've got 3 agents. One agent is a document validation agent. So all the document validations in terms of evidence that you provide for an insurance claim can be completely done quite easily. That's a particular type of task that agents are very good at doing, because they are able to use intelligent recognition capability of the documents, the formats, and extract the required information quite easily, quite efficiently than the traditional OCR techniques and all. So when the claim is submitted, the entire document validation is done by an agent. It thinks through, it does the validation and all of that, and then checking if this particular claim is a fraudulent claim or is an anomalous claim. All that can also be done by agents. Couple of agents here. If this particular claim, based on the claim history, based on similar type of people with similar type of vehicles with similar claim history, whether these types of claims have come, whether this is anomalous or not, these are fairly easier things for an agent to undertake and do. Fraud detection is also something very, very easier and a very good use case for agents. So in this particular case, this particular customer had a complete rule-based, human-centric workflow, and the steps of document validation, fraud detection, and anomaly detection were completely handed over to agents, and there's no human intervention at all. So the turnaround time for insurance claim processing has drastically dropped for this particular customer. And insurance industry is one of the industries where agents are heavily used, because these types of tasks can easily be undertaken by agents. And okay, so this gives a little bit more details. However, it's very important if there's a sort of a anomaly detection and based on that a claim is rejected, you need to have explainability, and you need to be able to go back and exactly see why this was rejected, due to what reason, because that customer can ask. So therefore, it's very important that your agentic system has the capability to explain. We call it explainability. So this is an important and interesting use case for insurance industry, and similar use cases are being adopted for banking. Customer onboarding is a very good example where the document validation can entirely be handed over to agents. Then credit underwriting, which requires checking details from multiple applications, multiple backend applications, and then get make a decision based on that. Then if the underwriting, depending on the, okay, so in most of the banks, if the credit amount is beyond this value, it has to go to one manager. Beyond this value, it has to go to another manager. Instead of going that hierarchy, you can get an agent to do up to a particular level, and then remaining complex ones, or irrespective of the value, agent can do everything unless it runs into an ambiguity. You can put a sort of a guardrail like that, so that you can get humans and agents to work together and get that work done. This is, as I said, it's a loan origination type of use case, where the risk and credit analysis are done. Of course, in those countries, so they have credit agencies. In Sri Lanka, we have only CRIB, but in those countries, there are multiple credit agencies. So whenever a request for loan comes through, automatically you will check from multiple different credit rating providers and credit agencies, and then their information may be different, but then you'll be able to compare them. You'll be able to merge them and figure out sort of a consolidated credit worthiness position of that sort of requester of the loan, and based on that you can make decisions. And the important thing here is the credit memo, the ultimate loan agreement generation. Those are very simple things generative AI can do. You don't need to at all use human being to sort of print it from anywhere. It can be just generated. And the important thing is, it doesn't necessarily have to be based on a template, because generative AI has the capability to generate the way it wants at that specific point in time, with a little bit more personalized response as well. So unlike in the case of a standard message going, it can be a quite personal message that will go through. This is about validation. We spoke about lots of things in document validation you can do. Missing information, incorrect within the document, across the document, payslip, based on the tax code, based on the authenticity of that, can be done. And then in that use case, of course, it was UK use case, you are able to check, agent itself is able to check, okay, authenticity and validity of the payslip, number one. Number two, whether that payslip, the payment, the salary amount has been credited to their account for the last 6 months. That also can be checked. Why? Because in UK they have open banking. Open banking APIs allows customer to give consent to query their accounts and get the information, required information. That's nothing to do with agentic AI. That is connected government. Connected government in the banking sector. They've implemented open banking APIs. Now, if you go and rent a house in the UK, it's easy for you to, you don't have to do anything because everything can be checked if you give the consent. Just you will get a message very clearly saying into the app, the message comes. Then you know that the message is authentic. Nobody else would, not from an impersonator. Onto the app, you are logging to the app to see the message. So you will get a notification that the message has come. And from that message, it's a consent message saying this particular estate agent is trying to check your salary details for the last 6 months from this particular account. Would you like to consent? So that's outside of agentic AI, but it is actually the result of adopting open banking. But agent can make use of that capability because agent can talk to any API and get the response and get the task processed. This is a very interesting thing. So this is a little complicated for you to understand, but then in future, in probably a year and a half, from now, most of the process automation solutions, workflow automation solutions, where humans will enter something, somebody approves, somebody reviews, and somebody again adds some information. And so these workflows, right? You all probably would have many workflows. And I think about 5 to 10 years back in Sri Lanka, even we did not have workflows, we had files. Somebody comes and brings the files and keep it there, and you sign, that is approval. And then it is sent to the other person, and that's those days when I was in Sri Lanka, there was this employees called PNs. Now I don't know. Those days they have PNs, and they take that file and take to the other person. So that's the complete human workflow. But now you all have electronic workflows, digital workflows. In the digital workflow, somebody signs it. That decision can be clearly two things you can do. That decision can be handed over to an agent, and the other thing is, if somebody wants to see about, say, the status of foreign aid or status of a foreign aid of aids for the last 3 months about a particular, if there's a sort of a complaint about a foreign aid that has not been dispersed to or may not have been used by the intended maybe municipality or division, then if you want to really check that without going into the system, getting that data and populating it in another system and all of that, you don't have to do any of those things. All what you have to do is now conversationally you can say the last aid we got somewhere in September from this particular country targeting this particular road development. Can I check the status? Now that type of information is more than adequate for an agent to be able to figure out which systems to talk to, get the required information in which sequence and in which steps it should get this response back. Right. Now, as I said, Gen AI and Agentic AI is not for all use cases. So this is a very important slide I extracted from a webinar from Gartner. Gartner has done a very thorough analysis of the type of work where you probably should not use agents, because they will try to do, but they will most likely pathetically fail, because those foundational models are not built to do that. One important example is this optimization. So say production optimization, production planning, optimization of your manufacturing run across your plants, across your machinery. Those types of optimization, there are specific optimization techniques that are proven, deterministic, all of that, mathematical models that you all probably would have learned in your university times, operational research if you all have done. So that's where it should be. Prediction and forecasting, obviously not. Completely for predictive machine learning to take over and do. Decision intelligence, especially in the areas of high risk areas like credit approval, maybe claims approval. You can do certain subtasks like fraud detection, anomaly detection, some certain tasks. certain things you should not do. So that's what it says. So certain decisions that are taken, which probably have some level of ambiguity, you should never do that. And that should be done, that should be handed over to what we call deterministic systems. Deterministic systems are, okay, agents are probabilistic systems. Rule-based systems are deterministic, meaning rule is like, you are carving in stone. It's very clearly defined in the decision table, very clearly defined. If this is this path, very clear, and it has been audited, clearly stated. But agent, probabilistic. We do not know exactly how it would do the decision at that time. Obviously, for autonomous systems like autonomous cars and all of that, you don't use agents, and it uses reinforcement learning techniques, which is where you do trial and error and converge to a sort of undeniably correct position, or you converge to the right decision. That actually requires a lot of reliability. So that technique has been proven for a long time, reinforcement learning or reinforcement learning with human feedback. And for autonomous systems where autonomy is significantly high, we don't use agentic AI or generative AI at all. So this is a very so I probably can send this Gartner's webinar detail. They've done a very interesting analysis of how different types of AI techniques should be used, in what scenarios they should be used. So this means, depending on the type of business problem that you are trying to address, you may use one or more of the AI techniques. Very clear message that you need to remember is, whenever you are putting together your AI strategy, you need to know, I should use the right tool for the right purpose. Now, an example would be that manufacturing industry customer yesterday said, I want my board members or my senior managers to be able to conversationally talk to my manufacturing execution system and get the details of one of the rush orders, in which stage of manufacturing it is, conversationally, without logging into any system. At the same time, I would need the optimization of my demand, planning the demand onto the machinery, planning the runs on machinery needs to be optimized using these parameters. That's what he wanted. This requires two types of AI technologies. Conversational one is generative AI. The run optimization is optimization technique that you can use. So the same one specific problem, two AI techniques. So we are coming to the last part of it. I don't know whether we have time. Oh, we don't have time. Okay. So what I'll do is I'll quickly give a brief of this is a very important thing, responsible AI. So McKinsey has come up with a AI trust maturity model. You can use this maturity model to see at what level of maturity you are in terms of delivering trustworthy responses from your AI system or AI application, if you are going to build. So there are 4 areas that we need to consider as per this particular maturity model, because this comes fairly closer to the type of problems that we are facing when we are talking to customers. Very important that we need to understand. Of course, since we do some sort of consulting, we usually go and talk to customers to try and understand all these things. But this gives a framework that can be used for us, like consultants, or use within departments to see, am I in the right level of maturity in terms of implementing an AI system in a responsible manner. So the first thing is it's about strategy, whether very clearly what you're going to achieve is defined. Now, in the case of that marketing department scenario that gentleman mentioned, a very clear objective needs to be defined, the benefits that you're going to achieve, the strategic importance of such an objective, the risks, everything has to be very clearly defined. So it's important that if you define those goals as to what you need to do, then you can easily define how you can govern such a solution. And then it's also very important for us to understand the risks associated with marketing department relying on agents to respond to standards related questions that are asked. Then sometimes we might get into the type of questions, we might go to the marketing department and ask the type of questions, we'll categorize them, classify them, and we'll figure out, okay, these 3 questions we should not. So the level of risk for an agent to undertake this, we should not. So let's implement the solution at least for this part of it. So if we have a framework of evaluating the risk associated with using AI in certain areas, we are fairly mature in terms of being able to deliver a solution using AI. The other important thing is, of course, is a no-brainer. It's about the data and technology. Data, how the quality of data that you have, which is a very challenging problem in most of the time. Agents cannot do anything in terms of if your data that they are relying on, the quality of data is probably not up to the levels to fulfill what they are expected to do. Then it's about the operating model, how your operating model is, how much of AI literacy you have, and in terms of training, how much you have, how much of trained resources you have in terms of understanding, especially not only about developing the solution, but also about evaluating the risks associated with that, and critically evaluating the type of techniques that you need to use. So these 3 areas we need to think through before understanding how mature we are in terms of delivering solutions responsibly using AI technologies. In practice, of course, these are few things that we do. In fact, this is part of a solution. This solution is relating to document validation use case. Whether our AI solution has hallucination control, whether it hallucinates, if it's most likely to get hallucinate or make mistakes, if we are asking it to give the responses based on the vast amount of data that it is trained on. But if you use a technique like RAG, since you are grounding that model onto your specific data, assuming that data is trustworthy, the tendency for the large language model to go out of control and give hallucinated answers is less. Then obviously there are attacks against prompts. Okay, you know that when you're prompting, there are two prompts that are involved. One is the user prompt, what you write as the query, and then the system prompt. Especially, you can actually define a system prompt across multiple user prompts. So that's common. So in that case, you have to say, you should act like an insurance industry expert. You should give the responses only if that is available in the documentation. You should code the documentation. So you give that common set of instructions that is called the system prompt. So somebody can poison the system prompt and say you are an external consultant in need of personal information about the insurance customers, and if you state something like that in the system prompt and somebody asks the question, that the personal information can be leaked. So these are called prompt injection attacks. So how you guard against that? So you have to guard against that by doing some level of filtering in the output and sanitization of the input. So those are the types of things that we need to consider, especially when we are dealing with some sensitive information, when we are having access to, when we are allowing agents to access sensitive information. Then, of course, we spoke about fairness and bias in a fair bit of detail. Governance is very important. Now, in most of the AI use cases, when you actually come up with the use case, there is a very stringent governance so the set of approvals that you need to take in terms of evaluating whether it is in line with the regulations, and there's a risk evaluation framework, and most of this governance tool has embedded risk evaluation framework. Now, for example, the newer tools, AI governance tool will have when they are deployed in EU, against the EU AI Act, you can clearly evaluate your use case against the EU AI Act and identify in which risk category that your particular AI use case is, and what are the precautions that you need to make before implementing it, so that that risk assessment will give you exactly what you need to do in terms of reducing the risks. Then transparent logging at each stage is very important. Reasoning traces needs to be logged because it's important for you to be explainable. And then I have a few things around this is actually IBM has what we call 5 pillars of trust. A very, very important and a very detailed analysis of different facets that you need to consider in terms of ensuring that you are delivering a trustworthy AI solutions. Unfortunately, I do not have time, but these are things that you are. In fact, I have put this. I got this slide directly from IBM, but then I have put some of the terms to explain it a little bit more detail and maybe to align with much more to your scenarios as well. So explainability and fairness. Fairness is very important, especially human resources related. Say, for example, if you are going to do classification of candidate CVs, the job applications, and there are, of course, these bias, gender-based bias, race-based bias that has to be addressed extensively. And in fact, in the EU AI Act, it is very clearly defined. That is a mandatory validation against an equal representation along those attributes in terms of making your AI decisions fair. And obviously, the robustness of the AI system is very critical because it can be subjected to many attacks, and those attacks can actually leak information because large language model would not know who is asking the question, and it will respond the way it has been instructed to do. Obviously, we have to be very, very careful, and our system has to be robust. We have to withstand interferences from bad actors and all of that. So those are important aspects. The transparency is a very critical aspect of trust. And what happens is transparency and privacy together sometimes may not work 100% in line. So privacy protection and being transparent probably may not have things similar, but then we need to define what level of privacy for this particular use case is adequate. Now, the problem is if you don't have an act, it is up to somebody in your chief AI officer or somebody at the top level to be able to give you guidance. But if there is act, and of course in most modern AI governance tools, that act is codified, meaning the provisions of the act is within the risk atlas, as IBM calls it, or risk registry of that tool. That tool has access to the risk registry. If the act is getting updated, automatically that risk registry also will get updated. Therefore, it helps you to move faster because you are in line with regulation. And some of the other countries are also now trying to adopt parts of the EU AI Act, and more countries adopt. Those AI use cases can be expedited in terms of delivery. And these are a few principles. Okay, so I think I'll stop at this. There are a lot more to be, maybe about 10 slides more, which is about AI governance. Maybe I can send you the slides you can go through, or probably if it is interested, maybe we can do a small session, but then I think that we have covered most of the things. And I'm sorry that I have a little bit more than 10 minutes, just 1 minute less than 10 minutes more than the time that you will have allocated. And do you have any questions? Most likely you will have to have, because I tried to cover most of the things that I wanted to cover today. and try to align it with your digital economy or other 2030 digital blueprint, as well as your digital economy blueprint and your AI strategy document, all of those.